So everyone, those who are back, if you are not seeing, you can come a little at the front. So I welcome you all again from the break. I hope you had a nice break. Now you have to get connected again with the courses. You know, exams, all those things will be for next 6 weeks. So hopefully we will connect with our course also before this break, or what we have done in this course, engineering graphics. The aim is to learn how to communicate using 2D drawings, the 3-dimensional objects. That is what we are learning in this course. Perception and visualization is an important part of this learning. So you should always see that you are able to imagine if an object is shown, how it looks in the top view, front view, and the side view, all those things. We have done orthographic projections. What we have done in orthographic projections? Yes, in the previous classes, what we have done? Orthographic projection. In that, what are the units? Of one view, sectional views, missing views, and one more? Offset view. Offset is a part of a sectional view.
3D view.
Not 3D, it is 3 views.
3D view.
3 view for an object. How to draw the top view, front view, and the side view? This is called the 3 view. 3D we did not start yet. We are going to do it later. Okay. Now after that, why we did sectional view? There is a purpose for sectioning. Sectioning is nothing but cutting the object. What is the purpose? Why we are doing that?
This is inside features.
Yes, to see what we say, internal feature, inside features of the object. So there is a purpose, isn't it? Because sometimes top view, front view, and side view will not give you all the correct details, because all are hidden. Confusion may occur if there are more lines which are coinciding with each other. Okay, so we did. In the same way, auxiliary view is one more type of orthographic projectional view, which is done for inclined surfaces. An object having inclined surface, like this. This is the object having inclined surface, isn't it? Now, if I ask you to draw this object as a top view, what will happen? Inclined surface, you draw it on a horizontal plane. Similarly, in the front view. But what will happen when you draw it as a top view, as a front view? Do you have the exact same size? No, the size will get different, isn't it? So it is the drawback of top view or front view. It cannot show you or give you the exact shape and size of the object in the top view or the front view, especially for inclined surfaces, isn't it? You are getting? Now in the side view, okay, you get it as a line. So that is the purpose why we need this auxiliary view, to show the correct shape and size of inclined surface. That should be the key. So an auxiliary view, it is also called an extra or helping view, because auxiliary is the English word. Auxiliary word means helping word, that helps in understanding the object. Here it means a view which helps in understanding the inclined surface of the object. Now, what is the learning objectives of this auxiliary views is to understand what is meant by auxiliary view in a multi-view drawing. Okay, for a given object, we say how many views are possible? 6, isn't it? Top, bottom, left, right, front, back, like that. Out of these 6, 3 are called what? Yes, principal views. What are those? Top view, front view, and the side view. Now, this is a view which is separate, which is other than the top view, front view, or the side view, extra. Okay, so you have to understand what is meant by auxiliary view. We will just show you now. To know the basic procedure followed in drawing auxiliary views using AutoCAD. Of course, we are using all the way AutoCAD. So, what is the procedure that we can adopt? To practice drawing lines and curves while maintaining speed and accuracy. Here, there are 2 types of objects. Objects having straight edges or objects having curved edges. Curved means circular, elliptical, like that. What is mean by edge?
Corner.
Yes. No, corner is this. Edge is this. Okay?
The ball.
Yes. So it is a line. You can see. This is the edge. This is a surface. This is terminology using graphics. Of course, every subject has its own terminology. Physics has certain terms, chemistry has certain terms, like that. So this is the surface, these are the corner, this is the edges. Okay, this edge are straight lines, isn't it? Some object may have, like this object may have a circular curve, okay, like that. So there are 2 types of this. What is auxiliary view? Why we need auxiliary view? Auxiliary views are drawn for the inclined surface in an object to show the true shape and size of the inclined surface. This is the main word there, the catching word, the good word is true shape and size. True means exact, correct shape and size of the inclined surface. Why? Because in the top view, in the front view, what we draw is not the exact size. See, shape can be same. A rectangle is a rectangle if it is this size or this size, isn't it? But size matter, different sizes. So shape and size both matters over here. Inclined surface can have straight edges or curved edges or a combination of both. Okay, this can be straight or this. This is auxiliary. A full auxiliary view will show the top and the bottom surface of the inclined object. What does it mean? Show the top as well as the bottom surface. See, I am holding this object. Now, this is, look at my pencil. This is the line of sight for the top view. You know line of sight? Yes. Line of sight is the line through which when you are drawing front view, this is the line of sight. Okay, perpendicular to the front. When you are drawing the side view, this is the line of sight. Right? When we are drawing auxiliary view, the line of sight, instead of like this, we change it like to here. Line of sight will become perpendicular to the inclined surface. Now, since the line of sight becomes like that, perpendicular, what will happen in the top view? Do you see this surface?
Yes.
In the top view?
No.
Like this. Do you see this
No.
surface?
No.
Yeah. What is color? Yeah, yellow color. No. But when I change my line of sight like this,
Yeah.
you are able to see it, isn't it? This is the. So in auxiliary view, you will get not only this surface, but you will see some object, a part of it, some object, full surface. Okay. So this is what this sentence is, which we were talking about. It shows the top and the bottom of the inclined surface. It means that if this corner is 1, 2, the bottom is 1 prime, 2 prime. Every corner in a 3D has top and bottom, isn't it? So this point you should keep it in mind. Okay, line of sight. You know, just a figure. This figure we have used in missing views also. Simple object. If you draw the front view, what you will get? What you will draw here? It's simple. Two rectangles. This is the rectangle. This is the in the top view. One rectangle. In the side view, you see this triangular shape with a rectangle. So what you see is like this, isn't it?
Yes.
Top view, front view, and the side view. So how we utilize this to produce a fourth view, which is called auxiliary view, because it will be extra. It is not part of this. Okay. Now, these three views are called orthographic projection. These are principal view in orthographic projection. Auxiliary view or extra view is any view which is not one of the principal view. It's not a top view, it's not a front view, or not a sectional view. Because sectional view are part of the principal view. What is mean by that? Sectional views are the part of principal views. Three main. Because the top view you make it sectional top view. Front view you make it sectional front view, isn't it? So it is the same thing, you just do the sectioning. But here, no, it is extra, something you have to produce. Auxiliary view can be drawn from any two given images, objects. So if two views are given, you can draw the third view. If you want to draw the true shape of the surface A, this is the surface A here, inclined surface, auxiliary view of the surface, you need to choose the line of sight perpendicular to the surface A. Line of sight perpendicular to the surface A. Means, we will not look the object like this or like this, we will adjust the object or our line of sight in such a way that it becomes exactly perpendicular to this surface. Isn't it? Now perpendicular. This is what we did. Now what is the procedure that we will follow to draw auxiliary view? There are one or two or different types of procedure, but this procedure we will follow. It's simple, using two reference lines how to draw the view, fourth view. So first thing, two views will be given to you. What we will be doing? First thing, level all the corners in the two given views. Level the corners 1, 2, 3, 4 in order, either clockwise, anti-clockwise, any. So I level the corner. Second, draw projection line between the two given views. Just use layer, green color, red color, any color you want, you can draw the projection. Then the same corners you have to transfer here. Okay, like this thing we have shown you in the missing view also how to transfer corner. That is corner 1, 2. So here it is 2, 1. Why? Why we are writing? I am not writing 1, 2 here. The same line. Because this.
One and two.
Yes, it is representing 2 points. That's why there are 2. Order. 2 first, then why 1? Not 1, 2. One of the general rule of drawing is the best practice. How we follow is when you look which corner is appearing first. 2 is appearing first. So 2, 1. 1, 2 is 1. Now this is 3, 4. Here 5, 6, 6. So why we have 2 numbers here?
front and behind. Yeah.
Yes. Everyone should have this much perception because we are in the 8th week of the semester. We have done so much. Why we have only 3,4 for this corner, but here 5, 6 and 7, 8. Yes. Are you getting up to number? This is 5, 6 and you see in the behind there is 2, 7, 8. That has to be. In this object it is here. Some other object there may be 2 corners here or here, some wherever it is. Front and back. Okay? So like that. So transfer all the corners. Then next step is draw the reference line. Draw 2 reference lines, RL1 and RL2. RL is reference line. So what is reference line? Draw a reference line perpendicular to the line of sight. This is line of sight. Use offset and extend command to draw this. Okay, I will show you by opening AutoCAD. We will use offset at a distance of 30 or 40 and draw a line. Okay, and extend it. Extend means make it large so that we will catch all this corner. Then draw a second line perpendicular to the projection line between the 2 views. Okay, these are the 2 views. In between that you can draw. You can draw the line here or here or here like this. But what is the advice is choose it close to the view. Right? So why? Because next step you will know that we will be measuring distances from this line to each corner and we will transfer over there to the inclined surface. That's the procedure. 2 reference line. 1 reference. Okay. Where to draw this reference line is clear. Right? Where? Close to the view. Where to draw this reference line? At a convenient place. Say at an offset of 30, 40. But don't draw it far away that when you start drawing it will go out of the frame. You know, you have a A4 size frame to frame. Is it? So you have to use your own judgment. Now, after that, we have to use perpendicular command, perpendicularity, and draw lines perpendicular to this inclined surface from each corner. From this corner, this corner, this corner, this corner. Lines perpendicular. How to select? We will go to the object snap and select that perpendicularity. I will show you by opening AutoCAD. Now, after that, what it is, how these 2 reference lines will help us. From one of the reference line, I will measure the distance from reference line to corner 1, reference line to corner 2. Suppose the distance from reference line to corner 1 is D1, say 50, 50. And from reference line to corner 2, say it is 50, 1 far. You have measured. Now, what will be the distance from reference line to corner 4? To corner 4?
50.
50. It's D1, isn't it? So by measuring 2 distances, I measured all the corners. Isn't it? How to measure? Go to the dimension, say linear, and measure. You know how to measure distance as you are doing dimensioning, isn't it? That is one of the procedures. Or you can write the dtext command and you can use the distance. Then this distance which you have measured from here, you will transfer from this reference line onto the inclined lines. What does it mean? The distance I measured from reference line to number 1, I will transfer it on the inclined surface from reference line to that number 1. Then what I measured from here to 2, say D2, I transfer here D2. Like that. Measure 3, 4, 5. So all the points from here is getting transferred to the inclined surface. That's what all the auxiliary view workout is. If you transfer these points correctly, then joining 1, 2, 3, 4, 5, 6 will give you the auxiliary view shape and size of the auxiliary view. Okay. Now, how to join? 1, 2 is coming and touching here. So the line which are going for 1, 2, these points will be on this line. This is the line for 7, 8. So 7, 8 will be here. 3, 4 here. 5, 6 here. Are you following this? Yes, because this is the step which is required. If you understood this, then it is very easy exercise. You measure there, you transfer the same distance. What does it? Literally, what you are doing? This figure, 1, 2, 3, 4 corners, you are transferring on the inclined lines from the here to there. Measuring the same from one reference line is your reference to transfer.
Can we see the result?
Yes. The next slide. See, I start joining 1, 2, 3, 4, 5, 6, 9. Now, 7 and 8 because it is behind the surface, so I will join it like a hidden line. Is it? Because line of sight is perpendicular to the inclined surface. Can you see that H 7, 8?
Depending on which view.
No, you are drawing auxiliary view. It's not depending. You are not drawing anything else. Means your line of sight is perpendicular to the auxiliary view. Here.
The one behind here is 5 and 8, not 7 and 6.
No, 7 and 8. 7 and 8, not 5 and 6. 7 and 8.
For the front view.
Because when you look at the object there, can you see the object here? This is the object you are drawing, isn't it? This is your line of sight.
Oh, yes.
Obviously, because your line of sight is perpendicular to the inclined surface. This is not perpendicular, but it should be perpendicular to the inclined surface, isn't it? So this is what it becomes hidden. As this represents the complete auxiliary view or showing the true shape and size of the surface A.
So also 5 and 8 it should be hidden, but because we have solid lines, so
Yes,
priority.
it goes to the priority. Now, why 6,5 is shown as a solid line? Now, look at it. This object is similar to it, not exact. Okay? Now, this is the corner. What is that? 3,4. Okay? Now, you have this corner. So, for the auxiliary view, when the line of sight is like this is visible. So, that's why this part is becoming as visible as a solid line, because it is outside the surface. Something inside the surface you cannot see, like these lines, you cannot see at the bottom. So it becomes, this is what the auxiliary view is to draw. Now sometime we will go, these are straight edge, very easy. The object is a straight edge, the corners are well defined, we can number it 1, 2, 3, 4. What if the object is circular? Okay, how you define the corner? That is what we will do now. Any question for the straight edges, how we draw? What is the procedure? The two views will be given to you. Number the corners. Okay? Draw the lines, projection lines. Then take two reference lines, RL1, RL2. Measure from one reference line the distance to each corner and transfer using second reference line on the inclined surface, on the inclined lines. That's all. After that you join, you get the surface. Any question? Now, sometimes partial auxiliary view is good for symmetrical object. Isn't it? Like in sectioning also, for symmetrical object we did something. What was that? Symmetrical object having symmetry. What we do? We did in section 8. Half section. Because we don't want to draw full half. It's the mirror image of the other part. Similarly, sometimes it is not necessary to draw complete auxiliary view, but only a partial. So that if it is a symmetrical object, you just cut and paste. For example, here, this one. A circle is here. I take this as a reference line. So if I draw this part of the circle, this becomes the mirror of it. Isn't it? Because it's a symmetrical object. So this is now auxiliary view for the curved edges. Curved means it's circular. See, in the top view it is a circle. In the side view it is like this. This is object, how it looks like. Now, in this case, one extra step we have to do, that is, in order to define the corner 1, 2, 3, 4, we have to slice it. Slice means draw lines. Cutting it. Just imaginary line, cut it. Now, what we will do, we will take this as the corner number 1. Why I am doing like this? Because it is a circle. It is a symmetrical object. Okay? So, if I draw the semicircle, the other half will be a mirror of it. Right? So, I took one here. Then, at every distance of say 10 millimeter, offset of 10 or 5 or 8, you do the slicing. Now, how many times should I cut? That's a question. The more that you cut, the better or accurate your view will be. But it will take time. Because the more you cut, the more will be the number of points. See, from here to here, how many points? 12. 12 points. So 12 points you have to transfer to the inclined surface. Now, if you take too little number of lines, your accuracy will be gone. In the learning objective, the third objective, what we say is speed and accuracy. So how accurate you are. Come. So you have to balance. Now, what is the general rule is if you have a circle curvature, then in order to make from a quarter of a circle, like from here to here, you should take this as point number 1, this as 6. If you have 6 points, hopefully your curve fit will be uniform. Okay, so minimum 6. Then again for this you have to take again 6 points. For this 12 for whole semicircle, if you have. Okay, thank you. Now, why? Because there is a basic that if joining of 2 points is a straight line, joining of 3 points is an arc. You know arc. Yes. So you should have more than 3 points to make a curve fit. This is called curve fit. I will come to it just a minute. Give a minute for how we do the curve fit. So this is the extra step. Now, once you do this, the whole procedure remains the same. What? Draw two lines, RL1 and RL2. Two reference line, measure the distance from one reference line and transfer the points to the second. I measure from here, what is the distance to 2? So 2 is here. I measure, I transfer. I measure, I transfer. Okay? Just I move this reference line here, it was here, so it was confusing, so I moved it up. But the procedure remains the same. Take the distances and transfer it. So what is the shape of the auxiliary view? It's an oval shape, oval shape or ellipse like that. Not exactly ellipse, but still, you can see. So this is the auxiliary view. Now, in auxiliary view, instead of taking reference line here, I can take this reference line at the center also, center of the circle. What will happen if I take this reference line at the center, the point number 1 and 11 will lie on the reference line itself. So I don't have to measure its distance. It is 0, isn't it? What we are doing, we are measuring distance from reference line to each point. If the point is directly on the reference line, you don't have to measure it, correct? So in that case, I will move my reference line here. So I will draw the object. This is point 11, point 1 and 11. Half part will come here, then make a mirror image. The other half will come. This is just to help sometime. It can save time also by thinking correctly. By taking the center of a symmetrical object as a reference line. Okay. So now, after doing this, how to join corner 1, 2, 3, 4, 5, like here we have. You have to use polyline command to join. Like you have this, okay? So for example, 1, 2, 3, 4, 5, 6, 8, 9, whatever other points. So use PL, polyline command. You know polyline?
Yes.
Yes. So this is a straight line, like this, like this. Then when you finish, press enter and right click on your mouse and say curve fit. P-edit, make a fit, curve edit.
Yeah, because too big.
Curve fit, what it will do, it will make it a smooth curve instead of straight line. So curvature is important in your printout. You should have correct shape and size with curvature. If you miss the shape or the size, you will get negative or not full marks or marks cannot be. Because the whole aim here, the purpose of drawing auxiliary view is to show the correct shape and size both. Okay? So transferring point correctly is very important here. Now summary, identify the line of sight. What is the line of sight? Perpendicular to the inclined surface. Then create layer, 4, 5, 3, any number of layers with different colors. Then take two reference line, RL1, RL2. Then of course measure the distance from one and transfer to the other. One important thing is you have to select object stamp and perpendicular when you are drawing the inclined lines. Okay, why? Because inclined line when you are drawing, can you have F8 on?
No.
No, you have to put it off because you are drawing inclined. Then what will happen? What you are drawing may not be perpendicular. That's why we have to set our line objective to perpendicular. I will show you, it's very easy. Then for curvature, for curved object, keep this in mind. For curved line, PL command, polyline command is to use and write P-edit and choose fit. Fit means curve fit. Right? So we even right click the mouse, it will go into the curve fit. So just polyline edit and here curve fit. Then you can make the lines hidden wherever the lines are hidden. You know, after you draw, you can yourself imagine which lines or which edges are inside the surface. The lines which are inside will become hidden because you cannot see. Can you see the surface here? Bottom. Your line of sight is like this. Can you see this line, this edge? No. So obviously such a line will become hidden. Follow the procedure and practice. Speed and accuracy are needed for this particular exercise. Any question or any clarification you need? Okay, good. Now what we will do is, I will use the given curves. This is the question which is loaded on your blackboard. Just you have to download first on your desktop, then open it. There are two objects. One is straight edge, another is combination of straight and the curved edge. So both will give you the practice how to do it. Fine. Now, I will show the basic, how to start, how to do it. It may take a little time because I am explaining also, but please try to follow when I am doing. See where my cursor is going and what I am saying about. Sometime when lecture is there, when I am explaining, I am giving you certain hints, tips, how to do it correctly. If you miss that, you will find problem, and even 2 hours you will not able, you will say, I am not able to finish it. So that the things while I am doing, don't do, and follow only on the screen. Okay, let us start with this. what the question says, draw the complete auxiliary view. You have to read it. Okay, draw the complete auxiliary view that include the true shape and size of the inclined surface A. So this is the inclined surface. This is the inclined surface here, A. This is the inclined surface. This is the surface which is in the shape of a D. Now, how to start? First, create some layers. Create new layer. Give some colors. Say green color. And this color maybe. Okay. I have yellow color and they said this. Don't use depth point. You know what is depth point. Depth point is something which you can draw, but it will not get printed. Okay? So the print, this layer is always off for the printer. So we will use this color and the yellow color. You can have even more than 3 colors also as you want. Now select one of the color, say yellow. Take a line, draw. See, this is moving. So what we have to do? F8. Now this corner. Now take this corner. Here, do you see? Each corner is matching one surface here. Yes?
Yes.
This. Now, what is the next step? What I will do is, I will go to layer 0 because numbers you have to show it. So I will take this text and give it a number, each corner a number, say number 1. Okay. Then press enter, and then go here, say number 2.
Does the sequence matter or?
Yes, sequence is better.
Okay.
Either clockwise or anti-clockwise, whatever you want to do. Because joining of points are important, so it will help you to join the points correctly. Okay, 1, 2, 3, 4, 5, 6. There are 6 corners, correct?
Yeah.
Now, I will number this corner. What it will be? 1, comma 2. Okay. Now, what about this corner?
6.
Why 6 comma?
No,
only
Six.
six.
Only 6. This is only one number, one corner. Just I am to try to put it outside so that it will be clear. Number 3.
5.
5, comma 4. Now this is the upper surface, this is the lower surface. So for the lower surface, what I will do, I will use the same thing, but I will call it 5 prime, comma 4 prime. So or 5, you know, prime means you can put like this, comma 4 prime. Can you see this? 5 prime, 4 prime, I am just zooming it.
Why don't we say 7?
Yeah, you can say 7, 8 also. Say, or you can write 5A, 4A, or star, 5 star, 4 star, it's just up to you. Okay. 7, 8 also you can do. Yes. But what will happen, if you give, you get confused. When the lines are here. You know 5 and 5 prime are the same points. From reference line, the distance will be same for them. So you have to follow. Although you can leave as you want, but what I would suggest is to use the same with a star, or you can give, for example, 3 star. If prime is not clear to you, then like this also you can do. Say 6 star. Then what will be here? Yeah, 1 star, comma 2. So it means that this is the reflection point, bottom point. There is a point here, point at the bottom. So we have done the numbering, zoom on. Now what we have to do? Next step. Draw 2 lines, RL1, RL2. So this line, I will draw one RL1 reference line between the 2 surfaces. So I can draw here, anyway, but try to keep it close to the surface. F8 on. This is our RL. Now, how to draw a second line? Use offset command and give a distance. For example, 30. You can use 40, 30, 20, anything. Then select the line, draw the line. Okay? Don't keep it very close, don't keep it very far away. Because the image will come, it may go and disturb the other or this. So you have to take it. Now what I will do is, I will use the text and immediately wherever is the reference line, you have to write RL1. And this is by layer 0. It means you have to show it in your printout. It will help us in correcting. RL2. So we will keep for our purpose, because if any point is missing, we can refer through the reference line. So this is this you have done. Then what is the next step? To draw lines which is perpendicular to the inclined surface. Now when I want to draw lines, I will use another layer so that it will be clear, say green color. Now I will select the line here, F8, F3. Now it's not allowing me to go. What I should
F8.
F8, yes. Now F8, I am free to draw. But how I know that I am drawing 90 degrees?
Oh, snap the
Yes. So in order to do that, you have to go here, object is snap settings and select perpendicular. You see, it's already selected. Sometimes it is not, so select perpendicular. Then say OK. Okay. This now see, when we have selected perpendicular, when I come here, you see a perpendicular sign. Can you see a green color here?
Yes.
That is the perpendicularity sign. So once it is there, just go straight with this line and draw up to where you want. Fine. Now this is the column. Let us see. Where is the perpendicular? Here. So I will go with this. Can you see this perpendicular sign?
Yeah.
On the line? Yes. So now it looks a zigzag line. This is only because my hand is shaking. It doesn't matter. It's about the resolution. Okay. But as long as you are taking perpendicular correctly, hopefully it will be okay. Okay. This is a little slow computer, so I have to do it slowly. Please follow. Here is the perpendicularity, you see, and you can see. But because I clicked there, I don't know now. So you take it out. Take the perpendicularity where the plus mark is coming. Okay, and put it. There is another way. If you think that finding perpendicularity here is difficult, then use offset. Say at a distance of, I don't know, say 80 or 100, 80, take this line and make an offset here. Now what will happen? When I take perpendicular sign, it will show perpendicular here, isn't it? So immediately I can click here. Afterward I will delete this line. You got? This is also a hint. That will be faster. Now what we will do, after that I will change the layer to this color. Then I will take perpendicular from this bottom. Now where is the perpendicular sign? Here is coming. Now the same thing should come here. Yes, here. This is the perpendicularity sign. So this is the one, corner number 6.
Why didn't